Okay, so today we will start with week 9 for microeconomics. And if you have any questions, please feel free to ask me. I'm just setting up the screens. Just give me a moment.
Madam, before we start off, I have a question from the previous assignment.
Yes. Can you mention, tell me which question?
Assignment 8, question 5.
Okay, I'll just look at it. Give me a moment. Okay, so I just opened question 5 in front of me. So can you tell me what exactly you have doubts about in this question? The question, it's assignment 8, question 5, right? This is, let us look at 80 workers who are trying to decide whether to work for one of the two companies, X and company Y. Assume both companies are equally appealing. The marginal product of labor for both companies is given in the following table. And now suppose 10 more workers come to town, what will be the wage rate now? Okay, so in the previous question, I think you were asked at a wage rate of $50, what will be the total demand for workers? And now you are asked that there are 10 more workers. So what will be the wage rate now? But this is 10 more workers come to town, not necessarily 10 more workers hired. So yeah, so can you tell me what you tried first? Like if you tried this before and what you got?
I did not know how to even attempt this one. The previous one, I understood that wages should be less than the marginal product of labor. So I tried out that one, that approach. But for the next question, I was clueless.
Okay, let me look at the question. I haven't solved this question before. Just give me a moment. So earlier your wage rate was $50 per hour, and we're seeing marginal product of labor for both the companies. So wage rate $50 and marginal product of labor. So basically for the previous question, what you did was you checked marginal product of labor versus the wage rate, and you counted the number of workers in each firm, right? So what did you get? Let me just check once. Sorry, T and oh wait, this is this different table. Okay, give me a minute. Marginal product is 50 T and workers. This is, I had calculated this before. Okay, then you have more workers. Okay, give me a few minutes to think about it. I will take this question up in the break because I also need a little time to think. I have not solved the questions. So let me get started with today's class. I will answer your question sometime in the middle of the class. Okay. I think these days they're not uploading solutions also, like fully. They've just given the answer, I think. Give me a moment. Okay. So I made a note of the question you asked. I will come back to it in the middle of the class sometime. Okay, so today's topic is cost minimization, right? So we'll be focusing mostly on just costs and different types of costs and how companies decide to the decision, like how they take the decision of how much to produce given a certain cost structure. So before we go to those type of problems, like this is a basic conceptual question in which you're given five statements and you're asked which one or which ones of these are true. So I'll give you a few minutes to read them and to think over it and tell me which ones you think are true. And you can type your answer in the chat box if you like. Okay, one person has answered C. You can think a little bit more if you want. You're asked which of these statements is true. No? Okay, just give me a minute. I'll just be back in a minute. Okay, so let's go over this one by one. First, let's go over what expression we have for, let me open the question. Yeah, total cost is the product of average total cost and the quantity produced. So first, let's see if this statement is correct. So what do we define average total cost as? Total cost divided by the quantity produced, right? So if you just flip this expression, you get total cost is equal to average total cost into Q. So the first statement is correct, right? This much is clear? Okay. Next statement is total cost is the sum of each short run marginal cost of all units produced. Now, this is a slightly tricky one, and you have to be a little bit, what do I say, a little bit aware of what you're doing. So let's write the expression for total cost. Total cost is what? Variable cost plus fixed cost, right? There are some inputs which are varying and some costs which are varying with input quantities and some costs which are fixed, right? Now, if we take a partial derivative, not actually partial also, we're just writing this in terms of Q. So if you want, you can make this more clear. We're writing this in terms of Q. Variable cost is in terms of Q. Now, if we take d by dq of total cost, we get d by dq of variable cost, right? That's all. Fixed cost is just a constant number, so the derivative will be 0, right? And what is d by dq of variable cost? That is marginal cost as a function of q, let's say, right? Therefore, even if you say that, if you're talking about short run, you have different marginal cost functions for each short run, right? So in each short run, you can define, say, marginal cost 1, marginal cost 2, marginal cost 3, whatever. Okay, now if you take integral of all of these, and if you sum it, you will still only get total variable cost. You are still missing the component of fixed cost, right? Whereas total cost is total variable cost plus fixed cost. So even if I ignore the integral, even if you just take a summation of variable cost over quantity, let's say this is 0 to Q naught or Q star, whatever quantity is produced, you can take the summation or integral of marginal cost over each short run interval, and if you sum that, you still only get the total variable cost. You still don't get the fixed cost. So that is why summation of marginal cost of each short run will not give you the total cost, unless exceptionally, unless in an exceptional circumstances fixed cost is 0, then it will be equal. But we're not talking about exceptional circumstances. In normal circumstances, if you're given that fixed cost is 0, then it's a different thing, but we're not given any such information. So therefore, the summation of marginal cost over several short runs is not equal to total cost. Let's look at the next statement then. Let me put the subparts here. Statement B, then statement C. Let me write this here in the expression, not true. Therefore, not true. Let's say therefore true. Okay, statement C is average total cost is the sum of average fixed cost and average variable cost. This we already saw just a few statements back. This is average variable cost plus, let's go back one step and just write the expression for total cost again. total variable cost plus fixed cost. Now divide the whole expression by Q. You get TC by Q is equal to TVC by Q plus fixed cost by Q. Now, each of these is what the expression is saying. This is average total cost. See, when you divide the entire quantity by, the entire cost, whether it is fixed cost or total variable cost, total cost, when you divide it by the entire quantity, you get average. That's what average means in our scenario. This is average total cost is equal to average variable cost plus average fixed cost. So this is true. Okay, let's go to the next statement. D, average fixed cost is always declining with quantity produced in the short run. So now we just wrote the expression for this. Average fixed cost is what? Fixed cost by Q, right? Now fixed cost is a constant number, right? This is a constant. And Q, as you go on increasing production, this is increasing with production in short run. Therefore, denominator is going on increasing, numerator is a constant, it's not changing. Therefore, left hand side, which is average fixed cost, will be decreasing with quantity produced. I'm sorry, there are some noises here. There's a workshop outside actually, and I hope the sound is not too bad. I hope you can still hear me. If the sound is too bad, please let me know. I will see if I can move to some other spot. Okay, let's go to the last statement. Total cost is always declining with quantity produced. Okay, so now we again come back to the same statement. Total variable cost plus total fixed cost, or just fixed cost. Now if you see, this is again, let me write this in terms of Q. This is a function of Q and this is fixed cost. Right now, total variable cost is normally going to be increasing with quantity produced, and that's just common sense. If you're producing one water bottle, you require a certain quantity of plastic. If you make 5 water bottles, you require more plastic. So obviously, cost is going to increase, right? But it may be increasing at a decreasing rate or at an increasing rate. That's a different matter altogether. But cost itself is going to increase. How fast or how slowly it's increasing is going to depend on how the market structure is for those inputs. But the cost itself is going to increase because total variable cost is increasing and fixed cost is well fixed. So total cost is going to increase with increase in quantity produced. It's not going to decrease. Total cost is going to increase. Average total cost may or may not increase, or that depends on the functional form. There will be a point at which, it's possible that average total cost is increasing and then decreasing, or it may be increasing at a slower rate. It all depends on the function, but total cost itself will be definitely increasing. Average total cost, we can't make a definitive statement. It depends on the functional form of the cost, but total cost is increasing with Q. Okay, therefore, statement is not true. This true, not true is about the statement given, not what I've written. Therefore, statement is not true. Okay, so this is the first question. It's just a little bit of conceptual revision about what costs are. So the second question is also sort of like that, a little bit of a revision about what we mean when we say this cost versus that cost, blah, blah. So question 2 is, a firm buys a forklift for $25,000 I don't know if the forklift actually cost $25,000, but let's assume it does. 1 year later, the firm finds that it is possible to sell the forklift for $20,000 since the forklift is practically unused. 2 years later, the firm finds that they can sell the forklift for $10,000. And 3 years later, the firm finds that the forklift cannot be sold at all. Right? Now, which of the statements is or are correct? That is the question. So again, I'll give you a few minutes to think over it. Please think about what is sunk cost, what is opportunity cost, what is implicit cost, and in each scenario, 1 year later, 2 years later, 3 years later, which cost is going to be how much. So I'll again mute myself for a few minutes. I'm here only. You can type your answers into the chat box and then I'll answer it. Any answers? No? So I looked at question 5 and I know how they arrived at the answer for question 5, but I'm not entirely sure if that approach is correct. So let me talk to the TA who said the question, and then I will answer your question, because I don't want to make up some explanation which is not correct. I mean, I know how they arrived at the answer, but I'm not convinced about it. So if that's okay with you, I'll answer the question for that assignment 8, question 4 and 5. I will answer it in the next class once I talk to the TA. Okay, let's do this question for now. So the firm has bought the forklift and spent $25,000 on it. Okay. Now, 1 year later, the firm wants to sell the forklift and it thinks it is able to, or it can sell the forklift for $20,000. So what will be the opportunity cost of the forklift after 1 year? It will be, the cost is basically equated to the earnings from the next best alternative, right? You have two options. Either you can keep the forklift, or you can sell the forklift and pocket $20,000. So if the firm decides to keep the forklift, the opportunity cost is basically the amount it is foregoing from the next best alternative, and that is $20,000, right? Because it is foregoing those $20,000 and keeping the forklift instead. Since it can sell the forklift for $20,000 after 1 year, the opportunity cost of the forklift after 1 year is $20,000, not $25,000. Is this clear? This reasoning for why the opportunity cost will be $20,000. The second statement is 1 year later, the sunk cost of forklift is $25,000. Now, the sunk cost is basically the amount you have already spent on some commodity, some capital, some equipment, something. And that is always going to be the same amount, irrespective of the passage of time. Like we take depreciation or whatever on the current value of that item, right? But sunk cost is the amount you have already spent on something, which you may or may not be able to recover at all. Because even what you are getting now, if you sell the forklift, is a different item. It's a different earning. It is not like you are recovering the original amount you have paid in some way. You can never recover that amount again. So sunk cost is always going to remain the same, and that is going to be $25,000. So B is also correct. 2 years later, the sunk cost of forklift is $15,000. This is not correct, because like I just said, sunk cost is always going to remain the same, because it's that one amount you have already spent at a certain point of time, which you cannot undo, which you cannot do anything about. Now, even if you think that was a bad investment, that money is gone, right? You can only try to recover something in some other way, like selling the forklift, but that particular sum is gone forever. So it's not $15,000. 2 years later, also the sunk cost will still be $25,000. Next statement is D. 3 years later, the implicit cost of forklift is $25,000. 3 years later, the implicit cost of forklift is zero, because 3 years later, the firm finds that the forklift cannot be sold. So therefore, you can get $0 by selling the forklift, which means you cannot get any money. So implicit costs are mostly costs which you cannot sort of reflect in accounting. They're economic costs, which are sort of like, how do you call it? Indirect costs. They're not actual costs. They're not explicit costs. Like they're not money you're shelling out of your pocket, but they are costs of, say, owning some equipment, or maintaining some equipment. Not maintaining as in not even maintaining actually, because that is again money you're spending in maintaining, but like just costs of keeping an equipment and foregoing some other better alternatives. So that opportunity cost is a kind of an implicit cost. So in this case, the opportunity cost 3 years later is $0, right? Because you don't have any next best alternative. You can't recover any money by selling the forklift. So 3 years later, the implicit cost is $0. And the sunk cost 3 years later is still $25,000, because sunk cost is the same amount. It doesn't vary with time. So that answers all these. I've not written anything because this is mostly just conceptual, but I hope this explains the difference between sunk cost and opportunity costs. So is this clear? Can I keep moving forward?
Madam, the opportunity cost, can you be a bit more explicit in describing it?
Opportunity cost is the amount of the next best alternative, like whatever you could possibly gain from the next best alternative. For example, instead of doing a PhD, I could get a corporate job and I could maybe earn, 2 times my current salary. That is the opportunity cost for me of doing the PhD. You get what I mean? So I may be earning whatever amount with my PhD, but instead of that, I could have used my time and resources and intelligence for doing some other job. And that job could possibly paying me twice of whatever I'm earning right now, maybe even 3 times. So the cost of doing this PhD is not just the bills I'm paying right now, but that particular alternative which I'm not using, which I had or which I could have. So my opportunity cost is that. You understand? Is it
Yes,
clearer?
madam.
Yes. So similarly, it is for any capital you own or any, for example, like if you're an entrepreneur, similarly, you spend a lot of money in acquiring the workers, in acquiring the capital. All of these are explicit costs because you're actually shelling out money in all of these things. But there is another cost associated with being an entrepreneur, which is that you could have been working in some other corporate job and been earning actually, which you are not earning currently. So that is an opportunity cost also, which you should ideally account in your calculations of what is the cost of running a company, something like that. Okay, let's move to the next question. Okay, the screen is not updating. Yeah. So in the short run, how are marginal cost and marginal product of inputs related?
Madam, before we move on to this question, if we could go back to the previous question once,
Yeah.
what would be the opportunity cost, not opportunity cost, implicit cost 1 year later and 2 years later?
So implicit cost in this case, we are only given the opportunity cost. There is no other implicit cost. So implicit cost 1 year later will be the same as the opportunity cost 1 year later, which is $20,000. Because 1 year later, the firm can sell the forklift for $20,000. So if it is not selling the forklift, then 1 year later, it is incurring an opportunity cost of $20,000. Similarly, 2 years later, it can sell the forklift for $10,000. Again, if it does not sell the forklift, it is incurring an opportunity cost of $10,000 2 years later. And 3 years later, opportunity cost or implicit cost is zero because it cannot sell the forklift at all.
Yes, madam. Thank you.
Okay. Okay, the next question. How are marginal cost and marginal product of inputs related in the short run? Mind you, they're asking in the short run. So what do you think? I'll give you a few minutes to think. You want to try? You can think a few minutes. Any answers? What happens in the short run? In the short run, capital is constant, right? Let me write this down. In the short run, K is constant. And therefore, in the short run, we normally will not consider, marginal product of capital as such. That calculation does not really make much sense. Because we are only varying the labor, we're not varying capital. So there's no, there's no real sense in calculating how something is varying when you vary K, because you're not varying K at all, right? You're not, differentiating with respect to K at all. So therefore, first of all, in this statement, you are given, let me open the question, four statements. Marginal cost is equal to W into MPL. Marginal cost is equal to W by MPL. Marginal cost is equal to R into MPK, and marginal cost is equal to R upon MPK. So in normal circumstances, in the long run, two of these would be correct, because you relate marginal product of labor and marginal product of capital with the marginal cost and the wages and the rate. But in this case, in the short run, that K calculation does not make a lot of sense. So therefore, it will be only marginal product of labor which we will connect this with. So let's see, marginal cost is basically is equal to, you can say, dTC by dQ, or you can also take dTVC. It's both the same thing. Or in another words, you could, or I'll come to that later. So now what is MPL? MPL is nothing but dQ by dL, or you can say delta Q by delta L, whichever way you want to express the two things. Now, considering the whole, the firms will want to maximize, what do you call that, bang for the buck. I think that's like the right expression. So you will get the expression to be something like this, right? This is the relation between the price and the marginal product of labor. 1 minute. So this is the expression we arrive at, relating the wages and the marginal product of labor. That's how you will compute the marginal cost. So, I mean, this is the correct answer. I don't think there is any other explanation required. So this is option B. So B is the correct answer in this case. Is pretty, actually not that complicated. The only question in this, or the only thing in this question was remembering that in the short run, you're not varying K. Therefore, the expression for marginal product of capital does not actually make much sense. Okay, now we come to questions on cost minimization. Now you're given an expression for quantity. Is anybody asking something?
Yes, I have a question, madam. Before we
Yes.
move on, how we
Yeah.
got to the option B? I'm slightly confused over there. Could we just be a bit more clear?
So this, I think, is there in your lectures. I didn't spend too much time because, marginal product of labor, so you, okay, give me a minute. So what the firms will want to do is they will, want to get maximum out of whatever their resources they're employing. So say marginal product of labor is the quantity produced per additional unit of labor, right? So let's say marginal cost into MPL is the additional profit they're making from additional unit of labor. That so far so good? Not sorry, profit. We'll come to profit later. I'll talk about the profit later. It's not, I said, is not wrong, but I haven't explained that part. Marginal cost is the cost incurred per additional unit of quantity produced, right? And marginal product of labor is the quantity produced per additional unit of labor. Therefore, what the company will want to do is the cost incurred per additional unit of labor will be equal to the wages which they are paying per unit of labor. The firms will always want to, manage their productivity and their cost. So this expression comes from there. Marginal cost into marginal product of labor is giving you the additional cost per unit of labor which the firm is incurring. You understand? This is what? This is dC by dQ, and this is dQ by dL. Therefore, this can be taken as dC by dL, and that will be equal to the wage. That is how the firm set the wage, basically. Does it make sense?
Yes, ma'am.
Okay. Let's go to the next question. So in the next question, you have a production function which is given as root k plus root l. K and l are capital and labor, and you're given the rental rate for capital as 5 and the wages are 50. So the question is, how much labor will the firm use to produce q is equal to 110 if it is minimizing costs? So you're given only the cost function, you're given the prices of inputs, and you're asking, and the question is asking that for us producing a certain quantity, Q is equal to 110, and assuming obviously that the firm is minimizing costs, what is the quantity of labor required? So I'll give you a few minutes to try and solve this, and then I will solve it. The maths in this question is very similar to how we were doing the utility maximization problems. So it's, if you want, I'll wait for a few minutes, otherwise I can solve it. So does anybody remember how we calculated, quantities of different goods, good one and good two, given certain criteria for utility maximization and a utility function? In this case, we have something called MRTS, which is sort of like the equivalent of MRS in the utility maximization case. And in producer theory, we do MRTS, we equate it to R by W, which you get from the condition of cost minimization. So let me write down the function and the questions. So you're given the function and you are given R is equal to 5 and W is equal to 50. And you're asked that Q is equal to 100, sorry, 110. Okay, we are going to minimize, what do you call it, costs. So in cost minimization, one of the conditions we derive, let me actually write it down, MRTS, I think by now you will all know, we define this as MPL by MPK. Again, this is just tradition. If you want to change the whole, flip the whole structure, if you want to do it MPK by MPL, you can do that, but you will have to flip everything. Then instead of R by W, you will have to use W by R, which eventually comes to the same thing. We have just arbitrarily taken L as x-axis and K as y-axis, but it doesn't, if you're, I mean, that's just what, you can call it as convention. That's just conventionally how we do it. There's no reason for confusion in here. When we write MRTS as MPL by MPK, we're just following the normal convention in microeconomics. And that comes from how you derive the isoquant. Somebody had asked me this question last time. That's why I'm again explaining it, so you are not confused about that. Now let's compute MPL and MPK first before we move on. Is delta Q by delta L, and Q is given to us as root K plus root L. So this becomes, root K becomes 0, root L is 1 upon 2 root L. Similarly, you will get MPK is del Q by del K, and this becomes 1 upon 2 root K. Now, MRTS is MPL by MPK. Therefore, this is 1 upon 2 to root L upon 1 upon 2 root K. This is basically just root K by L. So you have an expression for MRTS here. And like I was saying, this is a condition we get from cost minimization. If you want, you can derive it using any other method. You can use Lagrange, you can use substituting the variable, you can use any other method, you will get the same condition. MRTS comes out to be W by R. This is from the condition of cost minimization. Okay, we equate this to this. Therefore, you get root K by L is equal to W by R. Now we are given W and R. W is 50, R is 5. So we can just say that root K is equal to 10 root L, right? This is this is just a condition or a relation we arrive at, and we use this to substitute it into the original expression of root K plus root L. Q is equal to root K plus root L. Instead of root K, we just substitute 10 root L. We don't need to compute K at all actually, because we are asked only root L anyway. So Q is equal to 11 root L. If you want, you can just expand this here, plus root L. Q is equal to 110. We are given 110. 110 is equal to 11 root L. You divide 110 by 11, you get 10. Therefore, you square both sides, you get L is equal to 100. And if you want, you can compute K also in this way. Root K is equal to 10 into root L, or K is equal to 100 into L. That is 100 into 100, which is 10,000. And K comes out to be 10,000. I'm just writing it, even though it's not asked in the question. But this is how you generally approach cost minimization questions. So all we did was we just started out by first computing MRTS, given the expression for the production function. We compute MRTS by first computing MPL, then MPK. And we got an expression for MRTS in terms of K and L. Now, in this case, we get this to be root K by L, but it could be anything. It may even be, you know, involving only one variable. Sometimes it could happen like that, depending on what the function for production is. In this case, we get root K by L, and we equate that to the expression W by R. We are given W and R, so we equate it to W and R, W by R. And using this condition of MRTS is equal to wages upon rental rate, we derive a relation between the two inputs, K and L. Now, if in some case the relation comes out to be something else, it will be something else. In this case, it comes out like this. So we just substitute K in terms of L and we get the quantity L. I'm like just walking you through the whole process which we use. This is the process we're going to use most of the times unless some question is really weird or something, but that's the general process you use. Otherwise, if you don't use this process, you can always go for something like Lagrange method for optimization. But in these cases, these are relatively simpler questions, so you don't really need to use Lagrange, etc. Okay, let's come to question 5, which is actually also a conceptual question, not a calculation question. So which of these do you think is correct? Which costs are fixed even in the long run? I'll give you a minute to think. Any answers? No? Okay, so what we define fixed costs is like, you know, it's something which we mostly use in the short run case, right? We use fixed costs in the short run case. Why? Because it's like when you're varying in the long run, we assume that you can vary everything. You know, you can kind of dispose of your fixed costs, or you can you know, readjust your capital, etc. So it's not the same amount is what I mean to say. You may still have some fixed cost in the long run, but you can vary that amount which you had initially in the long run. Your fixed cost in the short run may not be the same as your fixed cost in the long run. I mean, in the problems you get, it may still be the same, but you can technically vary it. That is the one key thing which I wanted to point out. So this 1 minute, just Yes, sorry about that. I just had to reply to something. Yeah, so like I was saying, in the long run, basically the basic fundamental definition of long run is that you can actually vary everything. Now, most of the questions you get, you may not face that kind of a situation, which is why it might be a little bit confusing for you. That we just solved a question in which we did first fixed cost is like this, blah blah blah, but that is just like for numerical simplicity you are given those kind of questions, but technically in the long run you can vary your cost, and that is because fixed costs are the kind of costs like you have sort of bought a place, so you bought a house or a workshop or some factory, right? And that is like an amount which is fixed in a way, and or you can say semi-fixed, quasi-fixed cost. So those kind of things you cannot vary in the short run because you are sort of stuck with it, right? But in long run, meaning say in 5 years time, in 10 years time, you can vary that. You can change to a bigger or a smaller place, or you can change your machinery to something else, stuff like that. Okay, so fixed costs can be changed in the long run. Variable cost, of course, can be changed in the long run. The only cost which does not change in the long run is sunk cost. If you have spent money on something, that money is always gone, right? So that money you cannot recover or change in some way. The question is about what costs are fixed, meaning what you cannot change. So sunk costs are something which once you pay the money, it's gone, right? You cannot do anything about it. So those costs are the ones which will still remain fixed even in the long run because you cannot do anything about it. It's done and over, right? Done and dusted. Marginal costs, of course, vary in the long run, so those are not fixed. Total costs are like a sum of fixed and variable costs, so those are also variable. They are not fixed. So eventually the answer is just the sum costs, not any other cost. Okay. All right, let's go to the next question, and I will take a short break here. I will leave this question and I will let you solve it. Please attempt the question. The answers, options, whatever I've mentioned, are rounded off. This may not be the exact answer you get, just letting you know. But please try to solve this question, then I'll solve it for you. Okay, so I think that's enough time, I think, to attempt the question. Did anybody solve the question? No? It's just always better if you attempt to solve it first, then if I help you, you can kind of understand where you were stuck or where you might have made a mistake. Okay. I'll solve this question in two ways. Basically, so you know both the ways in which you solve this type of a question. So you're given the function is root k into L. Let me open the question on this. This is root k into L. You're given Q is equal to 100, R is 40, and W is 20. And then you can assume they're all in dollars or all, because I mean, obviously this is not in rupees. So this is in dollars. You're asked the optimal value of K and L for producing this quantity, assuming the farmer is going to be minimizing costs, obviously, right? So first, I will do this using the same method which I used before, and I think, I mean, obviously, ideally you should get the same answer, whichever method you use. So let's first compute the MRTS, which is MPL by MPK. MPL is equal to del Q by del L. Q is root K into L this time. That's what makes this question different from the previous question. So the differential for root L is 2 root L. So this is half K under root K upon L. And MPK is del Q by del K. This is also going to be half. And this is under root L upon K. Okay. So MRTS is MPL upon MPK. Half and half are going to get cancelled, so you can remove that. MPL is root K by L, and this is root L by K. So this becomes K upon L. Okay, we just readjust the numerators and denominators. Root L, root L into root L is just L. Similarly, root K into root K is just K. So you get MRTS is equal to K by L. And like I said, as per cost minimization condition, MRTS is equal to W by R is equal to K by L. Now we are given W and R, so we can compute this. This is 20 upon 40. It's 20 upon 40 is equal to K by L is equal to half. So you can derive the condition or the relation between the two variables from here. K is equal to L by 2, right? This is not too difficult. Now you're given the quantity, which is 100, and we just rewrite the production function, which is root K into L. So you get 100 into, now we substitute the value of K in terms of L. So this becomes what? Under root L into L upon 2. So this is L upon root 2, right? Therefore, let me write this on the next line. You can just write L is equal to 100 into root 2, which is 1.414 into 100. And this becomes 141.4. So simple enough. K is nothing but L by 2. So L by 2 is 141.4 by 2 is equal to 70.7, approximately 71, which is what we get as the answer. Okay, is this much clear? To get the answer for K comma L, which is 141 comma 71, now let's try solving this by method 2, which I consider is a little more cumbersome, but I think it's good if you sort of know that method. So if you write just the total cost function, this is WL plus R into K, right? Total cost is equal to, what is the value of W and L given to us? W is 20, R is 40. This is 20L plus 40K. This is the total cost function. Now we are also given the production function, which is root K into L. And we're given the value of Q. Q is 100. So from here, without doing anything else, just from this production function alone, we can actually compute or derive a relation between K and L, right? That's like pretty simple. Like, yes, you have to deal with an under root sign, but you can still derive it. Therefore, you can say root K is equal to 100 upon root L, or K is equal to 10,000 upon L, right? This is, I know it's not pretty, but you have at least a relation. So now let's number these equations. If this is equation 1, this is equation 2. So now what we will do, we take equation 1, total cost is equal to 20L plus 40K. Now instead of K, we plug in the value of 10,000 divided by L. So let's rewrite that this is 20L plus 40K, and instead of K, we write this expression. Now, if we want, I mean, I don't think you can simplify this any further actually. It's a quadratic expression. Now, what do? We have total cost in terms of one parameter, one variable actually, not parameter, which is L. Now, for cost minimization, we need to minimize this cost function with respect to L. So now let me write this. Minimize we will minimize the cost function with respect to L. So what do? When you actually this is the only variable right now, so we don't even have to take partial derivative. We just take a derivative of total cost with respect to L, first order derivative, and we set it to 0. And then if necessary, or if we get several alternatives, or even to just check, we take the second order derivative and we check whether it is greater than or lesser than 0. Okay, so first order derivative, let's take dtq by dl. This is just 20, and 1 upon L, when you differentiate it, it comes out to be minus 40, into 10,000 upon, no, I don't think I'll be 2. 1 second. Yeah, they won't, this is just, oops. So derivative of 1 upon L is just minus 1 upon L square, right? This we equate to 0, or in other words, you take the second expression on the other side, on the right hand side, you get 20 is equal to 40, why am I putting comma again and again, into 10,000 upon L square, or simply L square is equal to 2 into 10,000. Okay. You understand how I got this? This is nothing but you just divide 40 by 20, you get 2. And I took L square on this to this side. Let me mark this. You take L square here, you take 20 here. You get L square equal to 40 divided by 20 becomes 2. 2 into 10,000. So L is equal to root 2 into 100. You take an under root throughout the equation, which comes out to be again the same thing. 1.414 into 100 is equal to 141.4. Okay, this is the value of L. Now we can of course compute the value of K from equation 2. We derived this long ago from the production function. K is equal to 10,000 upon L, or you can just say K into L is equal to 10,000 or whatever. K is equal to, or you can just, instead of this also, you can just do this. Yeah, I guess it's the same thing if you do this also. Now you divide this and you see whatever answer you get, ideally you should get the same answer actually. Or you can put, if you want, you can also do it this way. 100 is equal to root K into L. It's the same thing, it's the same expression. So you just, yeah, it's coming out, I mean, it's the same thing actually. We got this expression from there only. Just compute the value of K. Can somebody do that calculation? Let me open the calculator. It should come out to be the same. Yeah, this comes out to be same thing, 70.7, so approximately 71. To get the same answer, just a different method. But I wanted to show you both the methods. So, whichever, depending on the type of question, you know how to use both the methods to solve the question. Okay, let's go to the next question. This is slightly different question. This is looks very straightforward, very simple, but it's a slightly tricky question because you need to think a little bit. So you are given that a firm's production function is given by Q is equal to minimum of AK comma BL, where A and B are both positive constants. This is what I was explaining last time is the Leontief technology function, right? Minimum of AK comma BL. I think I had explained it a little bit also. I drew the isoquants also for this production function in the previous class, if you remember. So this is that question, that production function. Now you're given that the rental rate of capital is R and the wages are W per unit time each. Okay. You're asked what is the cost function of this firm. You're not asked to compute. You're not asked to compute anything per se. You are just asked what is the cost. How do you write the cost function of this firm? So again, I'll give you a few minutes to think. You do. I don't know what is the problem with this. I don't want the generative summary. So just think over it for a few seconds or a few minutes, and then I will solve this.
Madam, the question is not visible. Can we shift back to that slide, please?
Oh God, I was muted. Did any of you hear anything? I don't know. Was I muted the whole time?
Yes, madam, you are muted.
Oh, I'm so sorry. I didn't realize I was muted. That's why I think you were not understanding what I was saying. Yes. Okay, I will repeat what I said. So in this, I'm still on the previous question. I just wanted to point out that even though we solved the question, there is one thing which you should always check when you're doing cost minimization. Okay, because we're doing the same thing in utility maximization and cost minimization, but there is a fundamental difference between minimization and maximization. Now we are doing the minimization here for total cost, right? So we solved this expression, we arrived at this expression L square is equal to 2 into 10,000, and then we take the positive root and we report the answer. Now, in this case, it so happens there is only one positive root and that gives you the correct answer. But in some questions, that may not be the case. In some questions, you may get two positive roots for L or whatever variable you're using, and you have to check which of those positive roots is giving you the minimum, because some of the roots may be giving you the maximum and we don't want to maximize the cost, right? So you have to be a little bit careful in these questions. So that's why what I did was I took the second order derivative, d2tc by dl2, and that comes out to be 40 into 10,000 by L cube, which is positive for all values of L which are positive. So L will obviously be positive. We cannot take L as negative. So therefore, the value of L we obtain as the answer is actually giving a minima for the cost function. You understand? We have to ensure that the value of L we're computing by setting this expression equal to 0 should be giving a minima, not a maxima, because otherwise we are maximizing cost, we're not minimizing cost. In some cases, it may be like that you're getting two values of L which are positive. If you get an expression something like L minus 2, L minus 4 is equal to 0, something like that. You could get two kind of L equal to 2 and 4. Now, which one is minima and which one is giving a maxima, you don't know. So you have to always check the second order derivative. And in this case, um, we are getting that as positive. Okay, now coming back to this question. In this question, you're asked the cost function of the firm, not computing the values of K and L, but you're just asked what is the cost function of this firm. This is Leontief technology, which we studied last time. So any answers? Anybody attempted? No? Okay. So let's go to this question. We write the question also. You're given the question as Q is equal to minimum, where A is greater than 0 and B is also greater than 0. R and W are the rents and wages, and you're asked the cost function. Now, the main thing to understand here is that if this is minimization, the Leontief function, right? So, minimum of AK and BL is what the firm is going to use. Like I was giving the example of, using a tractor versus a human being manually harvesting a field. Now, whichever is giving him lesser cost, they're going to use that. Like instead of using a harvester, the farmer can actually use the laborer to do the same thing, to clear out the field, to harvest the crop, right? So he's going to use something like AK comma BL kind of a function. And in this case, we know that if AK is less than BL, Q is equal to AK. And opposite, if AK is greater than BL, Q is equal to BL. Right? Now, the main thing which you need to kind of, you had to kind of guess, I guess, or imply or infer here is that as long as AK or BL are not equal, one is greater than the other, then the firm is only using one resource, right? You're using only K or you're using only L. And that is useless for the firm because, say, suppose I have one tractor sitting here and I have two laborers also, and I'm using only two laborers or only one tractor and the other is just lying around, right? It's a wastage for the firm. And the firm will ideally not want to do that because it has both the resources, but it's using only one. So the firm is always going to operate at the point at which AK is equal to BL. Okay. This was the main thing you had to understand or infer in this question, that it is going to operate at the point where AK is equal to BL. And the cost function then is what? Let me write the cost function. The cost function is normally what? R into K is W into L, right? Now, instead of this, another way to write this is Q is equal to AK is equal to BL, right? Therefore, instead of K and L, we can write this in terms of Q. K is equal to Q by A and L is equal to Q by B, right? This is the expression. So now if you go back into the cost function, this is 1 and this is 2. So if you go back and plug in the values in equation 1, you get C is equal to R into Q by A plus W is equal to, plus W into Q by B. We're just plugging the values of K and L. We're not doing anything else. Now in this, you take Q as common outside, we get R by A plus W by B. This is the correct answer, which is one of the options. Option B here. It's R by A plus W by B into Q. This is the cost function. Now, before I go to the next question, I will come to the next question, but there's one more question I wanted to take, but I could not get enough time to type it out. So I'll just write it out or I'll just draw it here. And the main reason I couldn't do it is because I couldn't draw the diagrams. Okay, I'm making isoquants here. Okay, so I'm writing the values of Q associated with each isoquant. Okay, this is one set. You can say this is diagram A. Just give me a moment. Okay, this is one set. Let's go to the other set. I don't know if you have reviewed this part of the lectures, but let's hope you have. Okay, this is and so on. Okay, these are two isoquants, two sets of isoquants. Now the question is, out of these two, which diagram do you think is representing increasing returns to scale and which diagram is representing decreasing returns to scale? Figure A and figure B. Think a little bit, and now this is very simple. I've given only two options. It's not perfect, but I think you get the idea of what is happening in this. These are isoquants. You have only two inputs, labor and capital. I have mentioned the quantity of output with each isoquant. You can see 10, 20, 30, 40, 50 written. The question is, which of these two is showing increasing returns to scale and which is showing decreasing returns to scale? Any answers? No? So what happens exactly in increasing returns to scale? If you increase the inputs if you increase the quantity of inputs by 2, the output increases by more than 2, right? That's what happens. Let me rewrite the condition for increasing returns to scale. Right? If Q is equal to f of k comma L. This is the condition that if you increase inputs by 2 times or twice, then the output is increasing by more than 2 times. It's more than 2 times of f of k comma L. Maybe 3 times, it may be 4 times, we don't know. Right? And similarly, we can write the condition for a decreasing returns to scale. Again, where f of k comma L is the maximum output achieved by the firm. So these equations explain what increasing and decreasing returns to scale are. Now in the diagram, which one do you think is going to be increasing and which one do you think is going to be decreasing returns to scale? Let me make this a little better actually. No? Okay, so let me first draw what should be constant returns to scale. For constant returns to scale, you have f of 2k 2l is equal to 2 times of f of k comma l, where q is equal to f of kl. Okay. Now in the simple case of constant returns to scale, use this color. Okay. And so on. So this might help you understand little bit. 10, 20, 30 are the quantities of output produced. So basically what happens in both these cases is, here this is 10, okay? Now let's say this is the input quantities of labor and capital. Now let's assume this is doubling. This is not exactly double, but all right, let's assume this is something like this. Not double, but you're increasing labor and capital both by the same factor. It's not exactly equal, but I think my diagram is not so bad this time. So you're increasing both labor and capital by this factor, whatever that is, 1.5 times, maybe 1.25 times, something like that, right? And you can see that output is increasing by almost exactly the same factor, right? This, what I've marked here. This is the increase in output. Now, if the inputs are increasing a lot, but output is not increasing that much, then what is going to happen? They're going to, also isoquants are going to move closer together or further apart. Because if output is increasing less than the increase in inputs, let me draw the diagrams here. Actually, it will be clearer from here instead of me explaining it. Okay, this is some quantity. See, the distance between the isoquants just shows how much you're increasing the inputs. Because the quantity is increasing by this factor 20 and 30, 40, 50. So the step increase between each isoquant is still the same in all of these graphs. In the left one, in option A, also they're all increasing by 10, 20, 30, 40, 50. In option B, also they're increasing by 10, 20, 30, 40, 50. In constant, also they're increasing by 10, 20, 30, 40, 50. So each isoquant is still increasing by a step of 10, but the inputs are increasing much more in this one. See, like in this option B, where I've drawn these green perpendiculars, you can see that here, you can see this is, you're increasing inputs this much first for the first increase in isoquant from 10 to 20. Then you're increasing input by this much from 20 to 30. Then you're increasing input by this much, even more from 30 to 40, which means to achieve that same increase of step of 10, you're going on investing more and more inputs, which means this is what? This is decreasing returns to scale, right? Is it making sense? You have to increase out inputs a lot more than the increase in output, which is what is the condition for decreasing returns to scale. Let's draw the same perpendiculars here in this diagram. This is the first increase in inputs. The perpendiculars are only showing the change in the inputs, not the outputs. The output quantity, how it's increasing, we have labeled on the isoquants. Now see, in this you can see from the perpendicular things that you're increasing much lesser and lesser. So if the first time you increased it by 2, next time you increase by 1.5, then you're increasing by 1.25. You're increasing lesser and lesser to achieve the same increase in output. From 10 to 20, maybe you increased by 1.5. From 20 to 30, increased by 1.3. From 30 to 40, increased by 1.2, which means you're increasing lesser and lesser to achieve the same increase in output. So this is increasing returns to scale. Is it making sense? And this is constant returns to scale, because the amount you are increasing is again the same amount the output is increasing. Like you're increasing the same quantity of inputs every time to achieve the same increase in output. Is this clear? Any doubts? It is a question I wanted to take up. I couldn't get time to draw it, so I've drawn the diagram, but I think it is, I mean, the diagram is okay. I don't think the diagram is bad. Any questions on this? Okay.
It's difficult to visualize this thing with that condition of increasing return to scale. Could we go through that once again?
See, the visualization, whatever you're doing, is just in terms of how much you're increasing the inputs. So these green perpendicular, not tangent, but these green guides which I have drawn, they're only showing how much you're increasing the inputs. So in the first case, you increase by this much. In the second case, you increase by this much. Then even lesser, then even lesser. and so on. You see, you're increasing much lesser and lesser and lesser. Whereas with every step of increase, the quantity of output is increasing the same every time. You're going from 10 to 20 to 30 to 40 to 50, but from each step increase in output, the increase in inputs is lesser and lesser and lesser, right? That is what we have defined as increasing returns to scale. Is it making sense? Try drawing the diagram yourself if you are a little bit comfortable with using online plots, creating plots online, then set a function, take values of L and K for different types of functions and see what isoquants come out to be as. You can play around with it a little bit. Okay. Let's do this as C. Okay, let me go to the last question. This is similar to what we did before. That's why I thought it's a better idea to explain this part first. In this, you're given the production function as this is sort of like a CES function. This is L to the power of rho, K to the power of rho, whole to the power of 1 by rho. And you're given the value of rho as 0.5. Rents and wages are both equal to 1. You are given that the quantity is equal to 4. You are asked to solve for the cost minimizing values of L and K. Now, in this particular example, you are given the values of W, R, Q, and rho. But this expression, this kind of a function, you could be asked to solve for it in terms of rho also. And I think this, if I'm not mistaken, this is given as a solved example in the Perloff book. If you want to derive and look at the general example for this particular case, you can look at the Perloff book. I think it is given there. And for now, I'm not solving the general example. That will take a lot of time. If you have doubts, I can solve it in the next class. But I'm just solving the question with the given values. So Q is equal to L to the power of rho, whole to the power of 1 by rho, and rho is equal to half or 0.5. W is equal to R is equal to 1. Q is equal to 4. So let's write the expression again. This is basically root L plus root K whole square. This is your expression. Okay, I've just simplified the whole root L and root the half thing. I've just plugged in the values of rho everywhere. That's all I've done so far. I've not done anything. So we can again do this the cost minimization way, in the sense of we can take the marginal product of labor and capital, or if you want, you can derive the cost function and take the derivative. Which edition? Okay, I also don't know which edition I'm using. I don't have the book here actually. Let me see. I think it's there in the slides, which edition I'm using. No, I don't remember the edition, but it's there in the Perloff book. I think it should be there in all the editions. It may change. I mean, the question number may change in the editions, but I think the question will be there. It's a solid example. If you are not able to find it in the Perloff book, I will share the details of which book edition and question number and all that, or I'll just solve it in the class. Okay, all right, let me go ahead with this. For now, let's just do this the old-fashioned MPL, MPK way. So, just 1 minute. Let me open the question once again. So, MPL by MPK is equal to W by R. W and R is equal to 1 in our case. So, the very simple thing becomes, this becomes very simple. Now let's just solve for MRTS, or we know MRTS as we just directly solve for MPL, which is del Q by del L, which in our case comes out to be 1 upon 2 root L into root L plus root K, I think. Let me check. Yeah, this is the question. This is the expression, right? So root L differential is 1 upon 2 root L. And then you take the differential for the whole. It just becomes, oh, there should be a 2 here, I think. Yeah, there'll be a 2 here. 2 upon 2 root L plus root K. Now MPK is del Q by del K. This will also be the similar thing. 2 upon 2 root K into root L plus root K. Okay, so MPL upon MPK. So this 2, 2, this 2, 2, this is all going to get cancelled. This is what root L plus root K upon root L, oh, I'm sorry, root L. And this is root L plus root K upon root K. So this gets cancelled. You get this is root K upon root L. Now we know from previous relation that root K upon root L is equal to 1 because we just derived that, right, in the previous part where we did this. In this case, fortunately, W and R are both same. That leads to this condition. Therefore, K is equal to L. Okay, so now the whole thing becomes very simple because then you have what? Q is equal to root K plus root L whole square. So this is 2 root K whole square. Just take square of the whole thing, 4K. Q is given as what? Q is given as 4, right? Therefore, 4 is equal to 4K implies K is equal to 1. And since K is equal to L, K is equal to L is equal to 1. So you get the answer that K is equal to L is equal to 1. This is the answer. So in this case, the question is very simple with the values that we have taken of Q and L and K. The general expression is a little unwieldy and will take a little bit more time. That's why I'm not solving it here. It'll take me at least 10 minutes to solve that, I think. But I also want you to try it out yourself. So take this general expression, L to the rho, K to the rho, whole thing to the power of 1 by rho, and try to derive expressions for this without assuming rho is equal to half. Try to derive the general expressions. That is a little more complicated, but yeah, if you're able to derive that, you will have a lot more practice of this kind of a differentiation and all that. Okay, all right. So this is it, I think, for today's class, unless you have any other questions or doubts.
Regarding that fifth problem of assignment 8, madam.
Yes, so that's what I said. I will need to talk to the TA because I know, I mean, I know how they got the answer, but I'm not convinced about it. So let me talk to them because I don't want to just make up some explanation and give it to you. I want to like check with them about the question and then I will answer it in the next class.
Okay, madam.
Yeah. Okay, so if there's nothing else, then I will end the class here. And next class, I think we will be moving on to profit maximization. And after that, we go to firm competitions. That brings the class to a close, this course. So like we will have a separate review class also. But if you are going to be writing the exam for this course or something, and if you want to review the material, if you have any questions, you can bring those to the class as well. Okay, all right. I'll see you next week. Thank you.